All right, what's up, guys? In this video, I'm going to pick up some more calculus here, and we're going to do another example of trigonometric substitution. This will be example number 3. Trig substitution is very important, so to me, you can never get enough examples. So let's go ahead and do it. So we asked to evaluate the integral of the square root of x squared minus 25 all over x dx. All right, so remember, trig substitutions, keep in mind they don't have to be under square roots. Most are, but they don't have to be. And remember, if I see a squared minus x squared, or the square root of that, then I do the substitution x is equal to a sine theta. If I see a squared plus x squared, or the square root of that, or conversely x squared plus a squared, because addition is commutative, then I do the substitution x is equal to a tangent theta. And then the last one is, if I see x squared minus a squared, or the square root of that, then that's just x is equal to a secant theta. And those are your trig substitutions. Okay. So we can easily tell here that this is a secant substitution. And so our a here is just going to be 5. So this would be 5 secant theta. We'll take the derivative of that, get dx. Remember, the derivative of secant theta is secant theta times tangent theta, so therefore we'll get 5 secant theta tangent theta d theta. And then we go to our integral and we plug everything in. And again, I don't skip steps in my video, so I'm going to plug everything in so you can see precisely what's happening. So 5 secant theta, don't forget that's being squared, and that's going to be minus 25. And then we're going to divide that by 5 secant theta. Multiply it by 5 secant theta tangent theta d theta. All right, let's clean the square roots up first. So let's clean this up. Okay. Well, it's just going to give me 25 secant squared theta minus 25, at which point I can just write that as the square root of 25 times the square root of secant squared theta minus 1. And when I take the square root of 25, I get 5. Remember that secant squared theta minus 1, that's tangent squared theta. So we would have the square root of tangent squared theta, or, which we know just becomes 5 tangent theta. So that takes care of the square roots. Now if we go back to the problem, we'll have 5 times 5. We'll have secant theta. Tangent squared theta, however, will be up top here. And then we'll divide all of that by 5 secant theta d theta. So we can simplify. All right, so our secants are going to go. All right, so we'll have 5 times the integral, and that'll just leave us with tangent squared theta d theta, which I know is, I can rewrite as 5, and then I'll have the integral negative 1 plus secant squared theta d theta. Okay, and then that just gives me 5. I'll get negative theta plus tangent theta, because the antiderivative of secant squared theta is tangent theta. Okay, so now we need to finish this up. So notice here how x is equal to 5 secant theta. So that means that secant theta is going to be equal to x over 5. Remember that secant theta That's just going to be hypotenuse over the adjacent side. Okay. Which means that the hypotenuse is x and the adjacent side is 5. Okay. And it always helps to draw a triangle, which we'll do. And we'll use Pythagorean theorem to solve for the other side. All right. Okay, so remember a squared plus b squared is equal to c squared. We already have the hypotenuse and the adjacent side, so the only side we're missing is the opposite side. Okay. Okay, so what that means is we'll substitute in. So we'll have a squared. If I square 5, I'll get 25. So this would be plus 25 is equal to x squared. Now I need to solve for the opposite side. So I'm going to subtract 25 from both sides. So you'll get a squared is equal to x squared minus 25. Take the square root of both sides. Yeah, I'm right on that. So if we take the square root of both sides, we'll get a is equal to the square root of x squared minus 25. Okay, so we draw a triangle now. So let's go down here. It's a horrible looking right triangle, by the way. I'm sorry. So remember, the hypotenuse is the longest side of the triangle. The side of the triangle is directly across from the right angle. And we already know what the opposite side is. Opposite side to x. The adjacent side was 5. And the opposite side was x squared minus 25. Hope you guys can still see. Looks like my phone about to die, so let me plug it up here. Alright, there we go. Okay. Alright, so now that we have everything we need, you just gotta go through the process of plugging some stuff in. Now, if you remember here, we got tangent theta. So remember tangent theta. Remember, tangent is opposite over adjacent, and that's the reason why we needed to do all of that. And so, given that we have basically all the sides for the triangle in this particular case, then that simply means that tangent would be the square root of x squared minus 25 all over 5. Also remember, we need everything in terms of theta. So if secant theta, secant theta. If secant theta was equal to x over 5, as we stated earlier, then that basically means that theta is equal to arc secant, or secant to the negative first, of x over 5. So for our final answer, we just got to kind of clean it up a little bit. So our final answer, we're asked to integrate the square root of x squared minus 25 all over x with respect to x. So our answer, I'm going to write as negative 5. I'm going to write arc secant. X over 5. Then it's going to be plus the square root of x squared minus 25. And don't forget about your plus c. And that's your answer. All right, so it's just another example of a trig substitution. So let me know if you have any questions. I'll be more than happy to talk to you about it. So we'll see you next time.